Hello friends, hope you are having a fantastic day today. So now we are going to do a very popular LeetCode problem. So without any delays, let's get started. So the LeetCode problem we are going to solve is called Symmetric Tree. And we can see that this is a LeetCode easy problem and also a very well-liked problem on LeetCode. The problem statement is very straightforward. We are given the root of a binary tree and we need to check that whether this binary tree is a mirror of itself or not, which we can see it from the example. Where notice that ignoring this root node, if we compare the subtrees of this root node, we can see that they are exact mirror copies of each other, which means this left node is same as this right node. Once again, this left node is same as this right node. And once again, this right node is same as this left node, which means we need to check that for any single given tree, whether this symmetric property is true or not. And this is actually very simple to do. So we are just going to do what we just used to explain this problem. If we understand we are given the root, then since this is a binary tree, it can either have a left node and right node, and once again this left node can also have a left node and right node, and same goes with the subsequent trees, and there can be many layers, as many layers as we want. The only condition we are checking is that for any single root value, we can only say that the tree is symmetrical if its entire left subtree is also symmetrical with entire its right subtree. And in that case, we need to check that whether the left child is the same as right child. And once again, even at this subchild level, we need to check for the grandchildren. So once again, even at this level, we need to check that whether this left tree is same as this right child, and also this right child is same as this left child. If that is the case, then we can determine that this is a symmetric tree, and we can keep on repeating or going down as many levels as we want, but the core logic remains the same, which means number one, we are doing two things. Number one, we are taking a bigger problem and we are actually breaking down into sub problems, and we are keep on repeating the same process for all of its children. So we are going to be using recursion to solve this problem. That is number one thing. Now number two thing is that we know in the recursion we need two items. Number one thing is that what is going to be the base case. So base case is quite simple. If any particular child does not have any more children, or if there does not exist any left or right node to check, then we can get out of the loop. And if we do get out of the loop and everything remains the same, which means we can return that this is a symmetric tree. That is option number one. Option number two is that at every given moment, we need to have a recursive function based on which we are going to be making our recursive call. And what is going to be the recursive function in this case? That at every single root node, we need to check that whether the left child of root is same as the right child of root or not. And we are going to be keep on repeating the same process. Once again, at the root node, we are going to check that whether the left grandchild of the root is going to be the same as the right grandchild of the root or not. So this is going to be our base case, that the left child is equal to right child and right child is equal to left child. This condition has to be satisfied, and then only we can keep on repeating the same process in the recursive manner. And basically that's it. So just the way I explained that, let's understand this with some example. So suppose we are given a value like 5, and then we are given subsequent values 3 and 3, and once again we are given further subsequent values. Let's assume like 4 5, and then this is also 4 5. So is this a symmetric tree? Yes, this is a symmetric tree because both of these values are same. This is also equal to this one, and this is also equal to this one, which means in this case we can return true. If we are given some other value, let's assume that over here we are given one extra child like 6, then we cannot complete the recursive call because this right subchild still also has a left subchild, but that is not present over here. So we can say that this is not symmetric. But in this case, if we did had another child like this, then we could have said that this is also symmetric. So this is the logic that we are going to apply. Now let's see the coded solution for this one. So first, this is the definition of our tree node, where every single node has a value. It has a left child and it has a right child. Now let's see our solution. So for our is-symmetric method, we need to return true or false or boolean value, and in the input we are given the root of the given existing tree node. Now first we are going to check for the edge case, that if the given root is equal to null, we can simply return true. If that is not the case, we are actually going to call our recursive method that is called isMirror, where we are going to pass in the left child and right child of our root node. Now let's see the recursive method isMirror. So as an input, we are having two tree nodes. So first condition we are checking is that if the given left is equal to null and right is equal to null, so both of these entries are null. If that is the case, we can simply return true, that saying that the tree is symmetric. If that is not the case, we are also going to check that if only one of them is null and the other one is not. If that is the case, then the symmetry has been broken down, so we can directly return false. If none of these cases are true, which means we still have to perform our iteration. So first we are going to check that if the given left dot value and the right dot value, so value of this left node and the right tree node, if both are same, then we are going to recursively call this isMirror method. For this isMirror method, we are going to take the left child of this left tree and we are going to compare it with the right child of this right tree. And same way, in the next iteration, we are going to compare the right child of this left tree with the left child of this right tree. So I know that this portion might look confusing, but if you just try to understand this using the image, things will become much more simpler. And I forgot to mention one thing during the code, that this code actually runs in big O of n time, because we are simply iterating over every single node just one time, nothing more than that. And in terms of space complexity, this is also going to be big O of n, because in order to fulfill this recursive stack, we might have to use big O of n space. Okay, so let's try to run this code. Okay, our solution seems to be working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is awesome and pretty good. So once again, I would be posting this solution in the GitHub repository where we have, which contains all of the LeetCode problems that we have solved so far. Also, I wanted to show you one more thing that might be helpful for your preparation. That is this Google document that I have created, which contains information about some of the popular courses that I have created. But this is the most important part. This is the collection of 130 most popular, most asked and most promising questions that has been asked at interviews. I have broken down these questions based on different topics. And also I have provided the information that how many times these questions were asked at specific companies. So this is going to be really helpful if you are targeting any specific companies, or if you are just targeting different topics, or depending on the different difficulty level. So if you want, you can start leveraging this, and I would be posting the link of this document inside the description of this video, so you can easily check it out from there. Thank you.